Good afternoon. Today, we have our final lecture in this year's series of talks on mobility analysis and planning for human-scale cities. The aim of the series is to explore how data analysis and planning can support sustainable travel behavior, shape high-quality and human-scale urban environments, and foster sustainability transitions more broadly. In the 5th season of the lecture series, we have brought public transportation into focus. We organized the series here at the Mobility Lab of the University of Tartu, together with Siiri Silm, Associate Professor of Human Geography. My name is Age Poom, and I'm Associate Professor in Urban Environment. Our technical partner is the University of Tartu Television, which takes care of the streaming and recording of the events. The recording of all lectures can be accessed from the lecture series website, which is transportplanning.ut.ee. Today, we are most glad to welcome here Dr. Amnir Hadachi, Associate Professor of Smart City Technologies at the University of Tartu. Amnir is the head of the Intelligent Transportation Systems Lab at the Institute of Computer Sciences. His research is located at the intersection of artificial intelligence, mobility analytics, and sustainable urban innovation. Amnir specializes in spatiotemporal data analytics, intelligent transportation systems, mobility modeling, and applied machine learning, transforming large-scale urban data into actionable solutions for smarter and greener cities. Today's lecture, entitled Multi-modal Modeling of Urban Mobility, From Data to Decisions, will examine how urban mobility has become increasingly multi-layered, data-intensive, and closely intertwined with policy decisions. So let's hear more from the lecture itself. If you have any questions to Amnir, please do post them on the chat box on Zoom. We will moderate them after the lecture. So now, Amnir, welcome to the lecture, and the screen will be yours.
Thank you. So good afternoon, everyone. And first, I would like to thank Age and Siiri for the invitation, and also the organizing team. I'm really glad to be here and honored. I'm trying today to take you on a journey a little bit to go into a trending topic. So everybody's talking about multimodal modeling of mobility, and also what are the challenges behind that. So I think maybe I will go quick. I'm doing a little bit of advertising to myself, but I think Aga already covered this part. Just to put in a context, I'm playing a little bit in this intersection between intelligent transportation system and mobility and modeling, and also how to use AI, but in an efficient manner. So we are trying a little bit to create this kind of lightweight models and also sustainable models, not only for the mobility, but also from perspective of computational power and also time complexity. So also I'm leading a lab, ITS lab, where we are working a lot on applied machine learning for applications in ITS. And of course, we have courses that we teach in this thematic. And please, if you are curious, you can check my homepage, or you can reach out to me also. That will be also fine. So as we know today, we are going through this kind of, like, everybody's talking about mobility transitions, the shifts that's happening, and we have also to think about this multimodal mobility, because we live in it. So we're not in the cities where only single modes of transportation exist, or we should not think about them as a separate mode. They are actually connected. And this is something that we do in our daily life. So there is something like, I will put some kind of an anecdote here, but I noticed, like, if you talk to somebody and you ask, for example, oh, how did you come to work today? Our first reaction will be like, oh, I came by bus, or yeah, I took my car. But actually, if you go in details and you say, really, you just, like, from home, you jumped into the bus, or how? And then when the person starts giving details, you start to discover, actually, no, they didn't just take one mean of transportation or one mode. Actually, they walked, maybe they took the bus, maybe even they used micromobility for the last mile to reach their destination, but they just ignore it. And this is the part where perception, how we perceive things, can affect actually the way we see how we commute daily. And the question is like, why this is happening? Why we have this perception? And this is where we see, which I will cover a little bit also later, that the time we spend in using one mode of transport affects our perception. And also the waiting, if you're waiting for a transit, for example, and you're waiting in a specific place, can also affect the way you will choose or plan your day when you're moving. And this is something really important, and it has also some kind of challenges how to model this. And this is something that we will cover today. So literally to put in a context of the goal of the lecture today, so I want to take you on this journey that we explore this perspective of multimodality, different layers, and also we'll go a little bit into the mathematical part because at the end of the day, we are modeling. I'm not gonna give like so much heavy mathematics, but at least I will lay down the foundation to anyone can easily translate his thoughts into the formulas, and then you can see how to use that. And of course, I will cover the data. So the data plays really an important role here, and we will see to which level and how it can help us to go into this journey of reaching real-world decisions and how to have insights from it. So to make this journey, we'll just, I will give you a little bit the roadmap. So at the beginning, we will try to see the motivation and the concept, why even we are talking about multimodal, why it's so important. Then we will move forward into laying down the mathematical foundations. So I will put like the main pillars and we will explain them. And I think the best way to do this, it's through examples. And especially when we talk about multimodal, it's easier when we give an example with the specific journeys and so on. And this is what we will do today. We will see also the data and how it affects the workflow. And we will see also, I would love to correct some of the perspective. Even us, when we are designing things, we start designing and actually we should not do that. There is some specific things we should put at the beginning, which I will cover today, before even jumping into the design and the solution or how the model should be. I will also cover some aspects with respect to the toolbox. We should not ignore that nowadays there is so many tools and models, simulators that can help us. So I will cover some of the main ones and also explain how to use them. It's not like a straightforward. Some are good for something and not for other things, so we'll see how to do that. And then also the extension. So when we talk about the extension about multimodal mobility modeling, we're going to the direction of MaaS, so mobility as a service. And I will point out to some aspects of it. I think you heard all of you about MaaS 1.0. It failed. I will show why it failed, but it's good. I see it as a positive thing. Failure can lead us to make things better. We know what's wrong now, and then we will try to fix it. And I think that's why we're going in the community in this direction of MaaS 2.0 and how to make things better. And we'll see also the applications and the challenges behind this. So yeah, so let's begin with the concrete mobility example to make it like easier to understand. So yeah, as I said before, like let's imagine that you have kind of like a plan. So you wake up in the morning and then you're going to your destination. So whatever your destination is, and then you do some kind of a sequence. And this sequence, we will call them kind of like a chain of modes. So you will go through some kind of walk-in, bus, metro, and then you walk again. And then we annotate them. For example, the modes, we just put an M, and then different modes, they can be like L1, L2. So this is depending on the modes. So what is important here, like to keep in mind, it's all this kind of like mode chains that we have. They can change the moment there is a failure. So what does it mean? It means, for example, I'm planning my journey. I walked in the morning, I took my bus, the bus arrived on time, then I went to my next mode of transport, the metro, and there is a delay. So as a traveler, I have two options. So either I will wait because somehow that day I'm flexible to reach my destination, or I have to take a quick decision to change the modality of my transport, either to call a cab or ride hailing or whatever. And this is where we understand that in the modeling parts, there is this aspect of uncertainties of the failure of the system. And most of the failures, they are happening in the connection points, the places where we transit. And this is where we go into this direction also of mobility hubs. So most of the things they happen in failures in mobility hubs. And for two reasons. Either the mobility hub, there is some issues in designing it, or it exists and we didn't even design it from an urban perspective. It just through time, suddenly it got constructed there, but we didn't take it into account properly. The city and the urban planners, it was not in the plan. It's just through the evolution, because we should not forget, cities are dynamics. So many players on the table, things they evolve, and sometimes we don't control that evolvement because parties involved are there is so many of them. And then yeah, so this is where so we should, to summarize it, we should think about the mobility as a connected system, and we need to model the structure and capture this kind of like a full chain of modes in the travel and also the policies. As you know, like traditionally when we talk about mobility, so there's all the time this question of demand and supply. So this is, I would say, the classic fundamentals. But we should take into account other ones. So I put them in a 5 structure because it's not only about the demand and the supply, based on the example that I gave you, this failure, change of situation, and then we adapt to it as a human beings traveling. So there is this behavioral aspect that needs to be modeled also. So it's not only about modeling the demand and the supply. So the demand, it's how many travelers, origin destinations, where they're going. And the supplies, it's our network. But we need also the behavior, how people, they behave. And then after that, we have the assignment, which we will assign the routes of our OD matrix. And then you get your final output. And this is where we will describe all the indicators of travel time, or I like to call it as a cost for edge. Why? Because it's not the only metric that we use when we are evaluating. It's more complex than that, and this is something that we will see. So yeah, so we can see a little bit this kind of, the output, it's not only about the travel time, as I said, but there is also congestions, crowd formation, there could be even events that you can depict and so on. So as we talked about the structure, so now let's move a little bit. So it's one of the key important part that I was pointing out, it's this mode of change, so the modalities. So let's a little bit focus on that. So as I explained before, that when someone says that, oh yeah, I took the train today to go to the office, and actually the sequence is more complex than that. So we have to build the whole sequence. And this is really important when we are putting the sequence to put it in details. And I will show later that sometimes how to get this truth, I will call it, from what's really happened with respect to your journey or trip. So, and this is also comes from the perspective that when we check multimodality and all mode of change, for the travelers, it's just one journey, but in the system, when you analyze the system, there are multiple journeys at different levels of modes of transport, or I will call it later as a different layers in kind of like, that's why I like also the aspect of GIs, because later we'll show all these modes of transport or mode of change, how they are represented. And I also, just to remind what I said before, so most of the bottlenecks are happening in the connection points. So that's where we have a lot of bottlenecks happening. And also, we should not forget, as the example, when there is a delay on the metro and then the traveler will change to another mode. Actually, we are intuitively, because of that issue, we are overloading another mode. So we are increasing the demand on that mode. And this is something that we have to take into account. So it's just I want to give this picture that the system is connected and there is also this cause effect there. So it's nothing disappears, actually it gets translated into another issue for another level. So if we go into the mode chain, and then so I like this representation, because if we go to the graphic theory, so usually we represent the networks with the vertices and nodes, but actually now we have another part that is added in the equation. It's our L, which is the layers. So literally our network gets more complex because you walk, then maybe you will jump to another layer, you start cycling, and then you go to a bus and so on. And we have to depict this. And to depict this, our graph changes from being like in two dimensions into 3 dimensions. I'm not adding the time, but this is something that we will add it later. And then we have, the moment we are jumping from one layer to another layer, then we have this kind of transition or transfer. And usually in our case, it's coming from the time aspect, how much time you waited to jump, or maybe you have to walk. And sometimes even the transition part can introduce another layer of mode into our equation. So now, like, you have this kind of like the big picture of the concept. So we have this mode change, we have the network layers with all its different layers. Now I think it's time to move a little bit and start putting the demand, and we will try a little bit to put it in a mathematical way. So the moment we talk about the demand, even when we are like discussing it, it's first thing comes to your mind, it's the trips. And this is what we will annotate it as T. So trips from an origin I to a destination J, and our origins, I think, I'm not gonna lecture about the origins, but as you know, like it can be like a location, a zone, latitude, longitude, so it's a starting point. And then to reach your J, you will go through different modes for a specific time. So and this is where we have this Tij MAT. So this is your signature with respect to the trips and all the indexes related to I and J. And then after this, what we need, so if I have my trips or journeys, I need some metrics of evaluation, so to understand what's going on. And to do that, it's, we still go to the traditional OD matrix, because at the end of the day, it's the OD demand. And we need to get a total OD demand for the trips. And this is where it comes, this sum of all the trips for specific modes. And this is where I get like the total OD demands that I'm expressing there. And then, of course, you sum it with respect to the origin destinations and also the time. And then you have this total demand. And then by getting the total demand, I need to understand some kind of, I will say, I call it like a rate or a ratio, it's more a ratio for the mode. And this is where I compare the total, the trips of respect to a mode into the total of all the trips on that mode. And then I get this kind of ratio. So why we are doing this, why I introduced these two indicators, because they are kind of a policy indicators. And how can you see them as a policy indicators? It's literally, imagine your system, it's running, and then you measure these two indicators, right? And then you introduce a new policy. And then when you introduce that new policy, changes, they will occur. And then you measure them again. And then you have a mean to evaluate how much I affected the old system with those two indicators. So it gives you a little bit, I will say, a preliminary insight how your system has changed with respect to introducing a new policy. All right, so literally if I summarize it, the demand tells us a little bit who wants to travel, right? From an origin to destination. And then the travelers also have alternatives. And this is where we talked about, they will plan their trips, and also there's the situation where the plan can change because of specific situation. And this is where it brings us a little bit to start to understand the supply. So we need to go into the supply side. So if we go to the supply side, so we have to build kind of like, as I call it here, link-int attributes, which is literally I'm evaluating the service or the quality of the network. And how to do that, it's literally, as I was talking before, we use travel time as a metric to evaluate my trip, but actually it's more complex than that. So it's not only just about travel time. It can be also a cost, capacity, reliability of that path. Is it comfort? Is it accessible? This is another thing. The accessibility also is really important in choosing mode of transport. And this kind of attributes, so this is what we offer to the traveler or what the traveler has in order to make the decision. So now we have the set of the attributes. Of course, I put examples. Your attributes can be other stuff. You can add other things. You can shrink it. And this is where I will talk also about how this is changing depends on what do you want to answer. Which we talked a little bit about it today with Aga, but yeah, so it depends a lot. What do you want to answer? Because your target, your final, I would say result that you want, it's to answer a question. So based on that question, defines also which kind of attribute to consider. And now we have this attribute, so we need to give this kind of like generalization for the travelers, how they choose. And to do this, we need the cost. So we have to build kind of like a cost for this. And this is where we kind of like generalize that cost. And so I think that the best way to do it, like, okay, there's a lot of things in that formula, but you should see it this way. So we have all those kind of like fragmented situations. So for example, you are in a vehicle, your walk-in time, waiting time, and then you have, for example, also financially, how much it costs you. Because sometimes our decision depends on how cheap it is, or how comfortable it is. So we take all those variables and you add them in your equation, and then you need to add some weights, how important each one. And this is where people, they are different. And this is my beta. So that's where you play around on the importance of a specific factor that you're taking into account. And this is how you create personalities with respect to travelers and their behavior in choosing a path. And this kind of interpretations, you can introduce them in your equation, and then you have different costs. And keep in mind that every user doesn't have a fixed cost. They can change for whatever reason happening during that journey. This coefficients that I'm introducing, for example, beta, I said this a lot. I take it like a, as educators in academia, after time of giving lectures, we start to see patterns that we're repeating ourselves a lot on some points. I will repeat it again here also. I still believe that surveys, even though they are like traditional old method, they are still the most robust ones. Because they're the ones who can allow me to find that beta, how to define it. It's through surveys. So that coefficient needs to be defined somehow, and through surveys, it's the best way to do it. And literally to give me this idea of like how the mode of choice is done by people, and also how they make decisions on the go. So now this generalization gave us like kind of an understanding of, so literally it's part of the behavioral model to estimate, literally if I put it in kind of mathematical, the likelihood of people choosing a specific alternative in like going from an origin to a destination. All right, so all this cost, weights, we have to translate them to some probabilities. So this is the moment where we use this kind of like all those formulas that we have. So we'll try to transform them to probabilities. So nothing complicated. So just the measurement that we had before. So all the utilities which I represent here in V, they are literally measured preferences that we got from our previous cost. And then we try to put them all together. Of course, in every modeling we do, you have to introduce some kind of uncertainty in a format of randomness. Error is always there. And the error, it's literally our behavior also. So things can change. And there's a lot of factors. And this is where we represent epsilon there as a random error that we introduce into the model. And then at the end, we put all the things together. And then it gives us this probability that a traveler N will choose specific mode M in their journey. And then you have this kind of probability. And what is interesting, it's the usefulness of those probabilities, because they give us literally this real behavior of the users when they are choosing different modes during different days. So it gives us this kind of power. So after we estimated this choice through the probability, so the next thing, so now we completed the behavioral model, then we have to load this into the road network with all its different layers. And this is what we call traditional assignment process. So then we have to move to the assignment and the network loading. And this is where we are translating all the demand into a flow. And I define my flow with X. So X on a link E at a period of time T. And literally, it's just summing everything we defined before. So the trips, the probabilities, and then an indicator if this link E, it will exist in our choice of the route R. And then you just put it all together. And this is where it's really, really interesting, because by doing this multi-modal mobility modeling, you can get, during that moment of assignment, when you're transforming into flows, you can start reading what is the status of your network, because you will start discovering overloads. And overloads in our case are congestions. So congestions are forming, crowds are forming, and this you can depict it. And this is the magical part, like I would say the exciting part in mathematics to just by monitoring one variable, and then you will see like how it changed with respect to the road links. So this row flows now, and the utilities that we saw before, how to put it, like, so if I show it to any like stakeholder or decision maker or policy maker, it will mean nothing to them. So we're still far from having something tangible that we can make a decision with. So and this is where we have to move forward. And that's why I see the next step when we come to the modeling, it's accessibility. I still see accessibility as a very important indicator. And this is the next step after this. So putting all these flows, it's not strong to make a decision or even to reach out for a kind of like decision support. So that's why I see that accessibility is one of the most important indicators when it comes to transport planning. And I see it this way. So for example, like you want to have this question, if I live in this area and I moved here and I'm looking for a job, what is the accessibility for jobs in my area in a radius of 30 minutes with respect to my home? Or for example, I'm getting old, I need to be closer to the hospital. So which are the areas where the accessibility is really fast for some specific amount of time to hospitals or any kind of education and so on. This is where we define the accessibility as origin destination using a specific mode. And in our case, this O here that I added represents opportunities to that destination, or I will call it attractiveness to that place. And then with respect to C here, it's the classical C we saw before, it's that cost, if you remember it. And this gives me this kind of like the cost from traveling to I to J with using a specific mode. And at the end of the day, this threshold that we put there, I like to call it, so in machine learning, especially when we talk about like some aspects in machine learning, we sometimes introduce functions for introducing penalties. So it's something similar here. So we have like this function that is a little bit kind of a decay. I will say that to the weight, it's literally to reflect how good to take that road or not, or how accessible that road is or not. So to get an understanding about specific roads. So to summarize, so literally this accessibility is really powerful. And it's easy to communicate also. So if I want to show it to anyone, it's easy to understand when I did like say, okay, this place is very accessible and this is the zone of all the accessibility, how far can you reach with it? And if you exceed it, then it's a different question or something. So it's really easy to communicate this. And then, for example, when planning, so of course you have to plan with respect to the neighborhood, you have to plan with respect to the gain access, and also there could be other observations. I just want to put it there that when you're modeling, you're trying to reach the reality, just keep in mind there is no perfect representation. So you will not be able to reflect the real world at 100%. So there is all the time this error there, and you should take it into account. So especially I will say to the people out there, so when you're modeling and you see that your model is not performing very well, don't be sad about it. It's part of the game. I will put it this way, try to reduce it as much as possible, but the error will be always there. So with respect to the data, so to support this, so we need to do some data injection there in our models. So we put the mathematical model, then we have to use some observations, and in order to model the situation, this is where we talk also about calibration. So as I said, the strongest one are still the surveys, and specifically they answer a lot this question, why people are moving, what's the reason to go there, and this is really important. Of course, when we talk about also consensus, this is about like more about the land usage, population distribution, and so on. Yeah, it's interesting to have GTFS and GPS and mobile data. Then we have really an understanding of the mobility patterns, even in local or large scale. Of course, smart cards or validation. This is really interesting. So it depends on the quality of that data. So in some countries or some cities, they validate when people they go in and then when they go out. This is great. Then you have an understanding of the mass usage of a specific mode of transportation from where they went in and when they exited out, and you can make really nice the model. In some cases, you can have just check-in and you have no idea where they exited. It makes things a little bit complicated. I'm not saying that it's impossible, but you can mathematically solve it to some extent to make a rough estimation there. And also there is outliers. People, they use the public transport and they don't validate. So there is also this part. And then we have also shared mobility. But just why I even brought data here like as a support is just to make also a statement that when you're dealing with multimodal mobility modeling, the data has to be diverse and it has to be taken into account as a whole. So you have to fuse it. I'm not going to go into details, but so that function that you see there, F, which fuses the data, so you have to find ways how to do that. The data is different. Some are qualitative, some are quantitative, and you have to find a way how to fuse that. And there is a lot of techniques, and I still will repeat it again, and it depends on your question that you want to answer. So when it comes also, so let's stay in the data and we dig more. If you have a lot of data, it doesn't mean that you should be happy and relieved. It's good for you if you have it, but there is a lot of issues with big data. So there is a lot of bias issues there. So even when it comes to mobility, and this is like I think one of the big issues, even if you have a sample size, some population, is it really representative? Me personally, I still question it. So that there is also this aspect, and also the representation inside the data for whatever minorities is there. So when you're dealing with this situation, especially we'll see later when with respect to modeling, you have to interfere. So either you have to do some enhancement to your data or augmentation to reduce the biasness there. And for example, that's why you can rely on semantic gaps and to fill them and so on. There is also privacy issues. I think we learned a lot, especially in Europe with respect to GDPR and the data privacy. I think we did like a big jump there, but it's still something that it has to be all the time on the table when it comes to the privacy of people, especially with mobility. It's really, I will say, easy to build a profile about people and their activities in everyday life. So it's really important to be cautious with respect of the data. So now that we discussed this aspect of biasness and also you shouldn't like trust the data at 100%. So we'll move now. So we did a little bit of conceptualization, mathematical, and then data foundation. So we'll move now a little bit to the practical working aspect of it. So if I put it into a kind of like steps, how to do it. So the first step to do, so I tried to put it in 7 steps to make it like easy. But so first of all, you have to frame a decision, and this is like where you're, as I said before, what is your question? What do you want to answer, or which kind of policy you want to evaluate? And then after that, you have to build this supply. So this is where you build the mobility alternatives, like the ones that they exist in your case. Then after that, you have to do this inferring the demand. And this is like who travels where, when, why. So you add this part. Then, as we discussed, you move into the behavior. So you try to introduce this, how people, they choose the alternatives. Then the next step, it's you have the observation, so all your data, and then you have to calibrate the model, so and validate. And this is where you're mathematically, we are pushing the model to converge to the reality. Imagine it like in mathematics, it's like a limit. When we compute the limit and we said, yeah, limit of this equal to this, it's not really equal to it. It just gets so close to it. So we try to do that. So we're trying to push the model to be as close as possible to what we observe. And after that, yeah, then you can do like simulation scenarios for cases and validation. And this is where you start testing your question. So you try to answer it. And after that, you just translate those evidence. And this is where you can translate it, for example, with some accessibility as an indicator, or you can have your own specific indicators that you can introduce into this. So let's closely go a little bit to the reconstruction of this supply and demand. So this is where like we have this physical network that we and we have some services in it, and then we have some choices. So before modeling behavior, so a lot of work is needed, for example, in making the zones, stops, links, time period transitions, even, for example, sometimes grouping. And this is like the classical things where you have to do a little bit of, I will call it like the preparing for the model. So there is also this, the model build, it's not something I will say straightforward. There is a lot of steps that has to be taken into account with respect to the supply and also the demand, also how to integrate it. So yeah, so this is, and then of course you take also the population distribution into account. So the next question is, when you build this model, how much trust can you put on it? So it stays this question. And that's why it brings us to the calibration and validation. This is where I need to see how much can I trust this model. So there is one thing that is really important. So when I'm calibrating, I validate with the observation, but then how I'm gonna test it. So it's really important to understand validation doesn't mean actually you tested your system. It's just you validated the behavior, but you need to test it with a different type of data. And this is where it gets complex. Complex from the perspective from where you're gonna get that data, how you're gonna do it. So I'll give you an example. So there is a couple of years ago, we built just like a model for mobility shares. And of course, we had the data to validate the calibration because we observed from sensors, so we had a lot of IoT devices, and then we validated the calibration through those observations. But then we needed to know how good are we actually? And then we went to the traditional way, deploying people in streets, counting. And this is one way to do it. So you have to go outside of that bubble of your input data that you use to create the model and test it. This is how it happens. It's not straightforward in all the cases, but it's very challenging. But this is the only way. You have to have some data that was not used in building the model in order to test it. So as I said, there is toolboxes. So there is a lot of methods out there. So I choose some of them that I would love just to point them because they are very interesting. So there's a couple of them. So I will start first by talking about 4-step OD models. And this is really interesting. So it's widely used for understanding the structures or the capability of planning on a network. So if you want to understand this, then this is the way to go. But it has some limitations. So you will struggle with the daily activities patterns. Doesn't go that way. If you have any trip chains, then it will fail. If you have any kind of dynamics like congestion, it will be also a problem. So it has some kind of limitations. But it's really good if you want to understand like the structure and capabilities of your planning processes, then yeah, it's the way to go. Then we have, for example, discrete choice model, which is, usually it's a mixed logic. And what's interesting with it, it assumes that the travelers choose among alternatives based on utility. So it has this assumption, and which is kind of like really strong if you're looking for interoperability or understanding the interoperability in your utilities, which means literally like the values that you use in time and the willingness, that you will check this. Like if I'm choosing this because I'm willing to pay more money for comfort, then you will discover this through this model. So literally why I'm choosing this route and what are the factors that is affecting my choice. So it's a little bit checking this kind of behavioral model. So this is really good to, if you want to check that part. Then you have the activity-based and also agent-based simulation. And this is a little bit where our target, it's kind of like the advanced realism of the model. So you go into this direction if you want to really build a model as close as possible to reality. So you go into this direction. It's challenging. There is a lot of challenges there. But it's really interesting if you're like really want to go for a realism in your model. And it has also some advantage with respect to loop feedback with respect to heterogeneity. And also it's really interesting if you have a bunch of policy scenarios that you want to test. So this is something really interesting when it comes to this kind of models. And of course, we follow the trend. So everybody's talking about AI and machine learning. Then there is machine learning that can be used. There is a like massive amount of architectures. But you have to keep in mind, machine learning is used for forecasting. So it's more for prediction. And there is a big difference between prediction and explanation. The machine learning models will not explain anything to you, but they will just predict. But those predictions are not explainable. So this is something that we should keep in mind. But yeah, it's very powerful for predicting. Now, after covering this toolbox, and we saw a couple of them, and which each one what is used for, and so on. Of course, the moment we talk about multimodal, the big application that we have out there, it's mobility as a service. It's literally mobility as a service. It's a manifestation of multimodal mobility modeling into an application. So this is where the users, they use their phone, plan their journey through all the different layers or mode of change that we have with the mode of transport. But why it failed the first time? And this is a big question. And why? It's really simplistic. It's just the financial model behind it is not sustainable. And why? Because there is every different mode of transportation, there is a different player on the table. And all of them, they have to make profit. And you cannot provide a profitable service to all these players with the cheaper price to the clients, which is us, the travelers. That was the bottleneck there. And even if companies, they tried, they managed to operate locally, specific zones, like in the city, to some extent, but in a very difficult way. It was not smooth. But the moment they tried to expand, because any company who's doing mass, you need to enlarge their scope, because the profit is when I can go from here to Barcelona, and everything is planned for me through one application, and everything is paid. And that was not feasible to be done. And that's why the whole idea has to be kind of like rethought completely from the core of it. And this is just to show because it's not only the financial part, because also the behavior of travelers is complicated. There is a lot of behavioral modeling needs to be into account there. So if we move to a kind of like a practical part, which means if I do multimodal modeling, what can I answer with it? So it can give you an idea, as I said, about mobility hubs design, or even discover them, the ones that you don't even know they exist in your city. You want to do some kind of increase in enlarging the cycling infrastructure, or evaluating the quality of road of your infrastructure in cycling. So it can allow you to do that. You can do kind of evaluating the emissions and building strategies how to lower the emissions, and also to evaluate, for example, shared fleet for you. So it literally allows you to answer major questions that our cities today are facing in order to transit to zero emissions and sustainable and reliable urban mobility transportation. Of course, as I said, there is no perfect model, so there is limitations, and I think we need to be clear about them. The data can be biased, so it can be a problem. Also kind of like, I will say, misinterpret purposes. So this passive data, so when people they move and why they move, it's not that easy sometimes to get it. And sometimes even get it from the people, right? It's challenging. So even the source itself, sometimes it's not reliable. Or you have to ask that question at the moment of the people are doing the journey. So yeah, you see, there is also this complexity. The mode of change also is complex. So I like to call them like, this is like this transition. It's like wormholes. It's like in space, jumping from one universe to another one. Or like, so it's some of them are fixed. You know that they are there, but some of others are moving, depending on the users, where they want to change. So you cannot like find those kind of transferability areas. So some of them are fixed, you can know them, and others, they just appear and disappear depending on the people's behavior. There is also the operators, or like the cost of traveling, the capacity, how reliable to like the public transport is, and so on. So there is also this plays also a role. And of course, we have privacy, and then there is also equity with respect to the transport modes. So yeah, so there is a lot of challenges there. It's not to kind of like, how to say that there is no hope for multimodal. No, actually, the mode that there is challenges, that's exciting to try to fix them. But we have a lot of, I would say, work to be done with respect also to research. And this is where I'll say like there is this aspect, a lot of aspect that needs to be researched when it comes to the decision, how to move, for example, from the question to develop the appropriate model to answer that question. Also the calibration, there is a lot of work to be done. And also the fact when you move, so there is large scale. So having a citywide, it depends how large the city is. If you start to go large scale modeling, which is modeling, for example, 2 cities, 3 cities, or a whole country, the complexity also raises here. Another thing, it's the validation. So when it comes to validation, so we talk about validation each component, but actually that's the good way to do. Sometimes people, what they do validation on aggregated information. The aggregated part, yeah, it can give you a big picture, but actually you don't see what's happening at each level. And that's why the validation has to be fragmented to every component, so you get really the idea what's going on at each level. As I said, the error is coming from everywhere, and when it gets accumulated, you see just a big picture. And when you try to fix it, if you don't know from where the error is high, how are you going to make it better? So you will just start guessing. So that's why the validation, you have really to kind of like fragment it to all the steps and check every step in your model that you're building. So from all the perspective. So yeah, so to summarize the little bit the whole picture here, so the main message is literally that when we talk about multimodal, it's not only about the demand and the supply. It involves behavioral theory in there. It involves the network. There is simulation, and in order to get this, we have to have appropriate indicators in order to translate to a decision support. So I see like multimodal is a very good approach in understanding how people, they move across different layers, or the mode chains, as I call them. And also you can have an understanding how services are attractive to people. Because if you want to push people to use some specific service, you have to understand why the people, they choose that service. What is the attractiveness that attract them there? And this is something important. And this will help also with respect to the policies. You should remember that some policies, when you introduce them, can reduce the attractiveness of some of the mobility shares that we are using. For example, you can introduce a policy and people, they will stop cycling. It's not the fact that the service is not available, it's there, but the policy made it less attractive or something like this. So yeah, so to put like a summary in one word, so I believe that it's multi-mobility modeling. It's kind of like a structured way to translate complex mobility or complex dynamics inside the cities into kind of an evidence. This evidence will be a mean for better making our cities more sustainable, and also making also our policies and investment inside the city smarter and more like, I would say, sustainable. Thank you so much. And I'm happy to take questions.
Yeah, thank you. Thank you, Amnir, for this very nice walkthrough of multimodal modeling or modeling multimodality in our everyday lives. So very much liked your structured approach here and the examples. So do we have any questions? And online audience, if you have any questions, do please post them on the chat.
Thank you, Amnir.
Thank you.
I also have two types of questions. First, that as I understand, the most of the models is to map the current situation, not so much for forecasting some or looking some what is happening for some scenarios. Was I right? You named this scenarios part also, but I feel that it's more like mapping of the situation.
Yeah, that's right. So, I mean, when we do any like mobility modeling, it's the first step or like the main purpose. It's understanding the situation, assessing what's happening, and then when you have this assessment, so you start understanding what's going on. Then you can kind of like go into the direction of forecasting it. Because anyway, if you want to forecast, you need some historical data. You need to know what's going on in the past till that's present in order to see the future. But yeah, you're right. It's about assessing what's going on right now.
Then comes my question: that how you take into account for if you would like to forecast this. The strategies or the decisions or what the policies have planned to do, not haven't done yet, but have planned to do.
Yes.
Is it also can cover somehow on these models, or have you thought about it, how to do it, or?
Yeah. So for example, so that's the when I was talking, for example, about those basic indicators at the beginning. So you have your model. And then you validate it, it's running, and you see how the whole mobility is working in your city. And then you introduce a policy. And for example, the city or any kind of entity wants to introduce some policy, and then through that policy, you will try to affect your model to see how it will behave if we, for example, policy decided to close a bridge on your city. And then you will close it in your model, and then you will run it again, and then you see what's going to happen. And then it will tell you how it will affect the movement. And the interesting part, this is something common that we used to do when we are doing just a single mode evaluation, like roads. Because at the beginning, everybody was just working on road traffic, cars. But now it's still the same practice. It's just you have the big picture. You're not just simulating just cars. You're simulating cyclists, pedestrians, e-scooters, and then vehicles, private and public transport. And then when you change the thing, then you will see the whole impact on the whole ecosystem, what's going on. And then this way you will evaluate what's the impact of that policy. Yeah.
Okay, thank you. And the second part of the question is, as you mentioned, these indicators, and you have this more qualitative or this behavioral side as like behavioral weight or some, it looks like some edge of the model's thing, not like the main thing in the model what you put there. And I mean that if it's like the people are not so much this rationally moving moving, and then it's as you what is I mean that what is your you have this indicator there, but how you calculate or what questions you use there? You named that you use the surveys, but what is the questions there, or how you got this weight of this behavioral thing?
It's a very good question. So that's the part when I rely on you and my colleagues from the social sciences part. But I can a little bit comment on that also. So one of the questions that could help, for example, is to understand if a person selected a trip, how often they change their mind about that trip. Like if I decided to go this way, how often that I will change my mind. Or they can tell you what are the reasons that pushed them to change their plan. And if we start to get this kind of understanding, what are the factors that affects people to change their mind? And also, if people just, sometimes just the mood can make you change your path. And this is something really hard to measure. But if you start asking people, what are the reasons? And you start to collect these reasons. We're not going to be perfect, but at least we will identify those factors and we can simulate them a little bit.
Okay, it doesn't mainly that you have this main behavior, and then you more get the weights about the changes or the randoms and the differences,
yes.
or something like this, not like a specific behavior.
Exactly.
Okay.
Yeah. Exactly.
Does it also mean that if it's like, for example, this accessibility, that mostly that in city context, I think the accessibility doesn't vary so much, that the main modes are accessible, and then the differences comes from some other indicators or measures, not so much this accessibility.
Yes, that's why I was talking at the beginning when we were talking about the behavioral model, the perception, how people they perceive. We can take the same path. I will like it, you will not.
Okay, yeah.
And we can take it even at the same time. We did the paths, all of it together at the same time, and we will have different experience. And this is the hardest part. It's this personal perception of the journey. And this is hard to find a way how to, but we can measure it. We can get a general distribution of it on a sample of the population. And this is where the survey can help to do that. And then if I have generally how it is distributed, then I can integrate it into the model. And then we will not be like 100% perfect, but we will be better if we didn't have it. So this is the...
And what do you use for these coefficients? That how much it is like usual, and how the proportion is this random one?
Yeah.
Can you say to have some what you have used already, or
what we used before? It's literally we try to measure it. So usually everything in nature is normally distributed. So we go with this principle. We initialize it as a normal distribution or a Gaussian distribution, and then through the surveys you start to see how much time it's fluctuates. So literally a heuristic analysis on those surveys, we try to see how the Gaussian distribution is not really Gaussian anymore, and then we have kind of a graph. How does it look like? It's literally, it's like I like this. I'm going a little bit to philosophy, especially Aristotle. So he talks about that maybe our world is just a shadow of the real world. You see, and it's exactly what we are trying to do here. So the way people they behave, I'm trying to get just the shadow. I don't want to try getting the real perfect part of it. It's really hard. It's nearly impossible to reach like perfection. But I'm just trying to get the shadow correct. That reflection. Yeah, exactly.
Okay. Thank you. I also give the possibility to ask for, no?
I had the same about how to integrate qualitative material into mathematical formulas.
Yeah. So another thing about the qualitative thing is there is ways how to start from text and conversation to start to create your own indicators from the language part. And then through that you can build kind of semantics. And then through those semantics we can transform them into vectors. And nowadays with the large language models, they are using this principle. So nowadays you can rely easily on LLMs to build from this qualitative information a nice quantitative vectors that you can inject in your models. And that's why this, I would say, this advancement that we, or this leap in AI that we had, there is interesting things that we can do with it. Yeah.
Before we go to our online questions, thank you for posting them. We will have them shortly. I would also like to ask about the comfort aspect. So we are broadly in the same box, like talking about the same things. You had put a lot of things into the comfort box in the model. It can take very different phases. Like, for example, do you have also health benefits there? Mm-hmm. Or do you have health threats?
Yes.
And even more, for example, the value of time, which you had time cost, which is not exactly the comfort part, but the value of time as a cost must not only be negative, but it can also be a positive aspect. If I go and take a public transit and I can read there, so which I can't do in the car. So do you, like, how I know that models can be super complex, but what's the, I don't know, even the business practice here? How to include those different aspects, positives and negatives, and the different values?
So it's a really good question. So when I was talking about them, I said then you can add more or reduce, and this depends on your question. Mm-hmm. That's why I said what do you try to answer after modeling? What is the purpose of putting the model into practice? Mm-hmm. So that direction of I want to answer this specific question will help you to choose which one to use or which one to consider.
Or which one to build.
Or which one to build, exactly. Yes.
Mm-hmm. Have you seen examples of models that treat travel time differently according to mode? So you have the same model, multimodal model, and for example, biking is considered with a positive aspect for travel time because I'm physically active, while driving is considered negatively. Or when we take another person, now the individual aspect comes in, another person considers driving time in a car positive because they can talk to their children. So how can you include, or do you have examples?
Yeah, I have an example. So there is a company who works on this. I'm not doing advertising to them, but I would love to talk about what they do. So for example, they have this multimodal model that they are using. And there is something really interesting with respect to their clients. They have this factor of safety. Mm-hmm. How safe I will use this road. So if I walk in that road, how safe it is. And this is where I want to point out to the fact that it depends on the demand. It depends what do you want to answer. You can have safety as a metric there. And even you can have it as a strong metric, which means it comes first. Mm-hmm. And anything else is secondary. Mm-hmm. You can have, for example, air quality. I want to take care of my health. I don't want to breathe I walk through a street that is really polluted. And we have the means. I think through you we saw the example in Helsinki. So there is a lot of type of multimodal with different factors and attributes depending on what is the most important. Either for the users or with respect to the question that we are trying to answer.
Okay, thank you. I will take a couple of questions from here. So Yasmin has asked, how can multimodal mobility models better support real-world urban transport decisions, particularly in improving public transport systems in cities with high dependency on private vehicles and limited data availability?
Mm-hmm. So as I said, first of all, the model will allow you to measure. Mm-hmm. And this is something that, as I pointed, you cannot change things if you don't measure them first. You should know what's going on. And then how to measure this behavior, we talked about attractiveness. Mm-hmm. So you have to build scenarios in order to evaluate the attractiveness of your public transport. Mm-hmm. So one of the things is to define the KPIs for attractiveness, and you try to measure them through the model. And after that, you can start introducing changes, small changes in your city and to see the impact on the measurement. I can give an example. So there is a moment, for example, in north of France, in city of Rouen, where the city, they wanted to measure if they build parking lots outside of the city and they push all the people to park there and then take public transport to all their destination inside the city, if they are willing to do it. So they wanted to create this kind of, because for example, in big cities, especially in European cities, I think in all other cities around the world, parking is like vehicles, it's a problem. So they said, okay, if we push everybody to solve this issue to park outside, and then we assure them that they can get to their final destination in the city smoothly, on time, just using public transport. And what they did, it's literally they tested. And in order to motivate people, they offered all the parkings for free for 1 day. And actually they did it in a sequence of days, but it was really interesting because it was forbidden to go inside the city with your car, but you can park anywhere outside and for free for the whole day. And they tested it. And after that, of course, they got feedbacks from the people. And it was really interesting. I still remember the results. Some people liked it, some they didn't. And what the city discovered, it's literally that it depends on the professional activity of the people. Some, it was okay for them, others it was not okay.
But this now only came from the real life test, this data. And now this data can serve to feed into another model.
Yes.
Now you can get these behavioral coefficients.
And then you get the behavior coefficients, exactly.
Yeah, yes.
Exactly.
So I think that the two other questions that we have here target the same type of questions. First, how can we stimulate multimodality using modeling techniques? And how can modeling support access to public transport while reduce private vehicle resilience?
Yes. When it comes to this aspect, and this is where, it's not my specialty, so we come to the urban planning and architecture. And this is where every city has to have a kind of an assessment of their urban design when it comes to accessibility. It's not just measure it through some data and then say, okay, my city is accessible. There is also this architecture part, the landscape part, it's missing. And this is something that even us personally, when we do analysis to Tartu or Tallinn, and it was like, oh yeah, the area is like, when we see the data, it's very accessible. But when you go there and you experience it yourself, and it was like, no, like there is a problem here. And you see that the road is not designed actually properly. And this is the part that is missing. So you have to evaluate the architecture of your city. And also, the moment we talk about transiting, then it's a question of mobility hubs. So you have literally to see if the areas where you have transiting is designed properly. There is something that I didn't talk about. It's really important to understand that if your transition point is designed properly, send somebody who has never been there and tell him to go from A to B and he has to transit. And see how much time he will spend on that transition. Is it easy to read the signs? Is it easy to orient myself? Is if I exit from the first mean of transportation, is it so easy to go? Or it will be stressful? Or it's so crowded? And this is something that us, when we are traveling, if I know the area, then yeah, it's fine. I can easily navigate. But if you go to a place that you've never been there before, and then you will see if it was designed properly or not.
Yes, and that's one of the, I think the notions are, we have to be cautious when modeling urban mobility so that the scenarios that we build into models, they might lead to different results, okay? And we find that this scenario will actually support multimodality or sustainable mobility the most, but people need time.
Yes.
And they need to actually be acquainted to the new system, not being the first time every day. And once they start picking up those new practices, only then the model outputs will be more realistic or more close to the reality. And because model outputs are always balanced already.
Yes.
We already, in a way, assume that people know how to behave and they will pick up the behavior, but it takes time.
It takes time, exactly.
Yeah.
Exactly.
Any other questions from here?
I can ask. actually. Thank you. Very interesting lecture indeed. I was wondering, you also mentioned machine learning.
Yeah.
And then you mentioned that the modeling is more used for explaining or
it's for forecasting
yeah,
and it's
yeah,
not for explaining. Yeah.
explaining, and
Yeah.
then machine learning for forecasting.
Yes.
I was wondering whether machine learning would somehow help if these changes or scenarios, they are not purely technical, but they are more qualitative. If some behavioral interventions are introduced, and then machine learning probably could help with that or not.
Yes. We can create something. Actually, it's a really, really interesting question. Yeah, I'll give an example. So, for example, this is something with respect to my own research when it comes to sustainability and safety. So we work on perception. And lately we're exploring if I feed to my machine learning or like the AI model, even though I don't like to use the term AI because we don't have AI yet. We have very well trained machine learning models. And I give them like a picture and I want him to understand the scene. And this is where we're exploring LLMs to give me context understanding. And this is where we can help to answer your question. So we can generate, I'm using the term generate, qualitative interactions to answer your question. But we have to evaluate this generated, but it is possible. Technically, it is possible. It's not only about forecasting, but we can generate also qualitative information. We can even create interactions. How good those interactions? This is for the research. Now we are in a level that we can do it. It's not a problem. Yeah, we have the tools. But yeah, it's really interesting. Maybe I will start digging there. But yeah, it's really interesting.
Yeah. I have one more question. How would you relate digital twins of urban mobility, or urban multimodal mobility to this multimodal mobility modeling?
Okay, so before it's a very interesting. When I was doing my PhD a long time ago, the term the digital twin was not there yet, and in my PhD I was imagining, and I still had like a vision where we have this kind of representation in a digital world of the whole city. And now after I see it, we are working in there, and to some extent it's happening. I believe that with respect to the digital twin, some aspects are doable, but not the full picture. Mm-hmm. I will say that the full picture is very optimistic, but reality, I don't believe fully in it. But some of the aspects of it, yes. But maybe in the future. But at this stage, we still have a lot of work to do and do a lot in that direction. Yeah.
Do you think that these efforts are worth continuing?
Any effort is worth. If it's at the end of the day, we are scientists. Even failure, it's a good result.
Indeed. Yes, we have.
So we can tell to everybody, don't go there.
We have to acknowledge indeed failure
yes.
well as a scientific result, and these failures are often underrepresented or published in research.
True. I like when I see a paper pointing out to failures, because then I know, I'm not going to go in this direction. It doesn't lead to anywhere. Yeah. No, failure. It's as you said. It's a good thing. We have to see it as positive, not negative.
Yeah. And with this notion, we will close our today's session. This lecture series has not been a failure. It has been a success as we see it. We close with this lecture also the lecture series for this academic year. But we hope to meet you all again in the next 6th season to be taken place next spring term. And meanwhile, you are most welcome to explore all the speakers and all the lectures from our lecture series website, transportplanning.ut.ee. There is plenty of material to explore until the next season. Thank you very much. Thank you, Amnir.
Thank you.
Bye-bye.